Greetings everyone and welcome to IS2IS Crash Course. My name is Mohammed Imani and I'm going to give you an overview of IS2IS here. Mostly I'm going to show you how you can configure your routers with IS2IS and implement this protocol in your network. Now, first of all, I'm going to give you a very brief summary of what is IS2IS and how you can use this, and then we will go and jump into configuration and show everything by scenario. So what is IS2IS? That's actually intermediate system to intermediate system, and intermediate system means a router. On the other hand, we have end system that is going to be a computer. So you basically don't work with computers, you are connecting your routers, and there is a very simple demonstration here. This is one of the routers, this is another router, and this is the link that we have here. Let's name these router 1 and the other one router 2. Now these two maintain kind of a neighborship like OSPF, because both IS2IS and OSPF are link state protocols, so they have similarities. For example, both of them have a database of the updates that they receive and send. They have hello messages to maintain their neighborship, and they have some criteria to create neighborship with the other side. On the other hand, we have an algorithm, shortest path first, SPF, that is run every now and then to update everything and calculate the best route to forward the packets. So all of these are characteristics of link state protocols, and there are some differences. However, for example, IS2IS is very good in flat networks, and by flat networks I mean something like an ISP. We don't have many areas in ISP. We only have one big area that you can add routers or remove routers from it at any time, and this is kind of a scalability. That means that you can change your network without many change to the topology. And OSPF, this is not the same. In OSPF you have one backbone area, and you can have this backbone area in one place, or you can split it into multiple places. As long as they have kind of a virtual link, that's okay to split backbone area. But we're using virtual link, you have some kind of contiguous area that is called the backbone area. Here we cannot split our backbone area. So in IS2IS we don't have such thing as backbone area. As a matter of fact, we have a flat network that is called level 2 areas and we have multiple level 1 area, or we may even not have any level 1 area. So we have, for example, this area. Let me connect it to my area that is level 2 area, and I'm going to write this for you. So this is our L2 area, but we have here L1, and the same is this one, and this one. All of them are L1 areas, and I'm going to speak about that, how we can configure this, how you have this. So we have multiple L1s, but one big level 2 area. Now I said to you that you can add many routers at any time to this L2 area. This is kind of scalability. And one thing that you need to know is IS2IS supports both IPv4 and IPv6 routing. So this is very, very good, and this is used for us. Now I'm going to say something else. IS2IS is not an IP protocol like OSPF or EIGRP or other protocols. This is kind of a connectionless network stack, CLNS. So this is not IP, this is not layer 2, not layer 3, some kind of layer 2.5 or something like that, if I want to resemble this to something. And this means that if your network stops this, only supports IP, this is not going to work. Let's say the connection between router 1 and router 2 is just a tunnel that supports IP, like IP in IP tunnel. This is not going to work because CLNS cannot be routed through this network. But if you have other type of tunnels or other type of mediums in between, that's okay. There is no problem. GRE tunnel, it's okay. And that's very good. Frame relay, it's okay. MPLS, it's okay. All of them are okay, and we have no problem with these kind of networks. Now, something else that is a little cumbersome, and some people are, kind of scared of that, is the ID that you assign to any router. So the ID is called network entity title, and you have network entity title in different ways. Let me tell you how. First of all, this has a minimum and a maximum. For minimum, you have 8 bytes. For maximum, you have 20 bytes. And how you can configure this? For 8 byte, let me go with a minimum. You have 1 byte of area ID, and I'm showing this in hexadecimal format. So 1 byte for area ID. Then you have 6 bytes for system ID. This is 1, 2, 3, 4, 5, and this is 6. And 1 byte for NSAP. N-selector, sorry. N-selector. So N-selector is always 0. Area ID is used when you are communicating between areas. Let's say, for example, between level 1 and level 2 areas. System ID is used inside areas. And N-selector is always 0, like I said. Now, if I copy this and add it here, I'm going to show you the longer format. First of all, you should know that the number of bytes, if you want to increase it to 20 bytes, should be even number of bytes. So you don't have odd number of bytes. So 9 byte is not gonna work. 11 byte, 13, 15, 17, 19, they are not gonna work. You cannot configure it on some platforms. On some platforms, you can configure odd number of bytes, but system is not going to work. Just accepts it and then stops working. So the number of bytes should be even. So the minimum is 8 byte. If I want to add more, I have 1 and 2. This is 10 bytes. 12 bytes. I can have 10 bytes. I can have 12 bytes. I can have 14 bytes. 16. 18. And 20 bytes. This is based on your choice. But most of the time, 8 bytes is quite enough, and I do not go for more than that. So, like I said, area ID is used when you are communicating between areas, let's say level 1 areas and level 2 areas. System ID is used inside area, and N-selector is always 0 and is not used for any specific thing. Now, level 1 areas have some characteristics that is very, very important. First of all, you should say that level 1 areas are kind of not so stubby areas, and this means that they can have, let's say, redistribution. And this means that it can be adjacent to an EIGRP, BGP, RIP, or another IS-to-IS network, and it can have redistribution. This means it can receive some routes from there, and then it is going to propagate that routes to L2 area. On the other hand, this is totally stubby. And this means that it is not receiving any routes from level 2 area. It just receives a default routes, and based on that default route, it can forward any packet that it has to other level 1 areas or level 2 areas. So we have this redistribution. On the other hand, we have only one default routes, and other routes are intra area routes. We don't have more than that. So this is the only thing that we have right here. Now, there are routers here that are between level 2 and level 1 areas. So those kinds of routers are called L1, L2 routers, right? This is like area border routers in OSPF. And they are kind of exit points between level 2 and level 1. So how can you, understand that this router is a level 2 and level 1 area? There is a bit in the messages, it is called attached bit, and this attached bit is 1, so it makes that router an L1, L2 router. So I'm going to continue this discussion in next section, but first of all you should know that most of the things that you need to know is covered in this part.